The old mathematician, Professor Eleanor Vance, adjusted her glasses, her gaze fixed on the chalkboard. She began, "Today, we explore the beauty of rings and fields." Her lecture hall, usually filled with restless students, was unusually quiet. "A ring," she stated, drawing a circle, "is like a harmonious society where numbers interact with addition and multiplication." How? She elaborated on how rings, with their structured properties, allowed mathematicians to approach complex problems systematically. "Think of it as a well-organized city, where every street and building has a purpose," she added, smiling slightly at the attentive faces. Then she moved to fields, drawing a larger circle encompassing the first. "A field," she explained, "is a more exclusive club, a sophisticated society where division is also possible, provided you don't divide by zero." She described how fields like the real numbers or complex numbers enabled mathematicians to perform more advanced operations. She discussed how fields provide a complete framework for calculus and advanced analysis. She told a story about how a young mathematician solved a complex equation by recognizing that underlying structure was a field. She showed how fields are essential in cryptography. "The concepts are abstract," she acknowledged, "but the implications are real." Then, she showed examples of how these structures are used in number theory, cryptography, and even physics. She explained that rings and fields are the foundation upon which much of modern mathematics is built. The students began to see these abstract concepts in a new light, understanding their wide-ranging applications. Eleanor then moved on to explain how abstract algebra provides a unified view of many mathematical objects. She explained how groups, rings, and fields are all examples of algebraic structures that are important in mathematics. She ended the lecture by saying that understanding these concepts allows us to build bridges between seemingly separate areas of mathematics. She encouraged her students to explore the fascinating world of mathematical structures. She added that understanding these concepts allows us to build bridges between seemingly separate areas of mathematics. At the end of the class, the students felt a new appreciation for the abstract beauty and practical importance of rings and fields, realizing they are not just abstract structures, but the language of the universe. Eleanor smiled. She had successfully shown them that these concepts were not just symbols on paper, but powerful tools for understanding the world.